Newton's rings, formation and theory. When a plano-convex lens of large focal length is placed on the plate of glass plate, a thin film of air with varying thickness is enclosed between the lower surface of the lens and the upper surface of the plate. The thickness of the air film is zero at the point of contact and gradually increase outwards from the center. The fringes obtained are concentric circles known as Newton rings. When viewed with white light, the fringes are colored. With monochromatic light, bright and dark circular fringes are produced in the air film. A source of monochromatic light S is at the principal focus of the lens L. A parallel beam of light falls on the glass plate B kept at an angle 45 degree. It reflects a part of incident light vertically downwards and falls normally on the plano-convex lens L of large focal length. A part of the incident light is reflected by the spherical surface of the lens. The other part transmitted by the air is reflected by the plate G. The reflected beam is viewed with microscope. Dark and bright circular fringes are produced. The formation of Newton's rings can be explained on the basis of interference between waves which are partially reflected from the top surface and those reflected from the bottom surface of the air film. If T is the thickness of the air film at a point on the film, the reflected wavelet from the lens has to travel a distance T into the film, and after reflection from the top surface of the glass plate has to travel the same distance back to reach the point again. Thus it travels the total path 2t. One of the two reflections takes place at the surface of the denser medium and hence it introduces a phase change of pi. The condition for brightness 2t equal to 2n minus 1 into lambda divided by 2, and the condition for the darkness 2t equal to n lambda, where n equal to 0, 1, 2, 3 is an integer and lambda is the wavelength of the light used. The thickness of the air film at a point of contact of lens L with the glass plate G is 0. Hence, there is no path difference between the interference waves. So, it should appear bright, but the waves reflected from the denser glass plate and has suffered a phase change of pi, while the wave reflected at the spherical surface of the lens has not suffered any phase change. Hence, the point O appears dark. Around the point of contact, alternate bright and dark rings are formed.